The high stages and swift currents that prevail during floods combine to increase the risk of accident and bodily harm. Therefore, it is generally not possible to measure peak discharge during the passage of a flood. An estimate of peak discharge can be obtained by the slope area method. To apply the slope area method for a given stream or river reach, the following data are required. The reach length, the fall, that is, the mean change in water surface elevation through the reach, the flow area, wetted perimeter, and velocity head coefficients at upstream and downstream cross sections, the average value of Manning's N for the reach. High water marks should be readily recognized. The reach should be sufficiently long so that fall can be measured accurately. The reach should be relatively straight, although a contracting reach is preferred over an expanding reach. The accuracy of the slope area method improves as the reach length increases. A suitable reach should satisfy one or more of the following criteria. 1. The ratio of reach length to hydraulic depth should be greater than 75. 2. The fall should be greater than or equal to 0.15 meters. 3. The fall should be greater than either of the velocity heads computed at the upstream and downstream cross sections. The steps in the application of the slope area method are the following. 1. Compute the conveyances at upstream and downstream cross sections. 2. Compute the reach conveyance equal to the geometric mean of upstream and downstream conveyances. 3. Calculate the first approximation to the energy slope, in which L equal reach length. 4. Calculate the first approximation to the peak discharge. 5. Calculate the velocity heads at the upstream and downstream cross sections. 6. Calculate an updated value of the energy slope, in which K is a loss coefficient. For expanding flow, where the flow area increases in the downstream direction, K is equal to 0.5. For contracting flow, where the flow area decreases in the downstream direction, K is equal to 1. 7. Calculate an updated value of the peak discharge. 8. Repeat steps 5 to 7 until the new discharge is close enough to the old discharge. This is usually accomplished within 3 to 5 iterations. The slope area method can be solved online using the SDSU Visual Labs slope area.sdsu.edu.